Microservices. If you are a developer, this is not a new keyword for you. It's a popular architecture that addresses the limitations and drawbacks of legacy applications. To understand the foundation of microservices, we need to take a look at the evolution of application design from monolithic to multi-tier to microservice-based architectures. A monolithic architecture is a traditional model of a software program. It's a singular, large computing network with one code base that couples all of the business concerns together. To make a change to this sort of application requires updating the entire stack by accessing the code base and building and deploying an updated version of the server-side interface. This can be convenient early on in a project's life for ease of code management, cognitive overhead, and deployment. Monolithic applications can be quite effective until they grow too large and scaling becomes a challenge. Making a small change in a single function requires compiling and testing the entire platform, which goes against the agile approach today developers favor.
As a solution to this complexity problem, the multi-tier architecture was used by the developers. Here, the application components are separated into layers based on technical functions. A common model is the 3-tier architecture. It consists of 3 layers. First, the presentation layer. It covers all the code and components responsible for the interaction with users through visual interfaces. Next, the logical layer. It encompasses all the business logic and processes related to the business functions. Then, the data layer. It deals with storing, accessing, and retrieving data when needed. Even though this addresses the drawbacks of monolithic architecture up to some extent, it didn't address the challenges associated with complex applications and systems quite well.
The microservices architecture, also simply known as microservices, is a software architectural method that relies on a series of independently deployable services. These services have their own business logic and database with a specific goal. Updating, testing, deployment, and scaling occur within each service. It doesn't reduce complexity, but they make any complexity visible and more manageable by separating tasks into small processes that function independently of each other and contribute to the overall product as a whole.
Basically, we can identify a few key concepts in microservices. As a developer, when you decide to build an application, separate the domains and be clear with the functionalities needed. Each microservice you design shall concentrate only on one service of the application. Ensure that you have designed the application in such a way that each service is individually deployable. Each service can be further refactored into smaller services having their own microservices.
Let's understand the architecture of microservices. We can find these basic components in a typical microservice architecture. Clients. The architecture starts with different types of clients from different devices trying to perform various management capabilities such as search, build, configure, etc. API gateway. Since client doesn't call the service directly, API gateway acts as an entry point for the clients to forward requests to appropriate microservices. Static content. After the microservices communicate within themselves, they deploy the static content to a cloud-based storage service that can deliver them directly to the clients via content delivery networks. Management. This component is responsible for balancing the services on nodes and identifying failures. Service discovery. This acts as a guide to microservices to find the route of communication between them as it maintains a list of services on which nodes are located.
Let's focus on the pros of microservice architecture first. Here, we have freedom to use different technologies, and it supports individually deployable units. Also, it allows frequent software releases. Since each service focuses on single business capability, we can ensure security of each of the services. When we are talking about cons of the microservices, there are a few that should be noted. The communication between services is complex. Also, more services mean more resources. Global testing is difficult because each dependent service needs to be confirmed before testing can occur. Debugging problems can be harder since each service has its own set of logs.
The best way to deploy microservice-based applications is within containers, which are complete virtual operating system environments that provide processors with isolation and dedicated access to underlying hardware resources. One of the biggest names in container solutions right now is Docker. Virtual machines from infrastructure providers like Amazon Web Services can also work well for microservice deployments, but relatively lightweight microservices packages may not leverage the whole virtual machine, potentially reducing their cost effectiveness. You can use Kubernetes for container orchestration and GitLab for pipeline automation. To manage asynchronous messaging, we can use tools like Kafka. For performance monitoring and logging functions, we can use tools called Prometheus and Datadog respectively.
As we wrap up, microservices empower scalability and agility by breaking down monolithic structures. Explore this concept for enhanced application development and deployment. See you in the next video.